Welcome to solving quadratic equations for Pre-Calculus Math 11. Today we're taking a look at the quadratic formula. And having to solve quadratics by completing the square is really common. And because it's so common, let's try and generalize the steps that we go through. So you need to remember how to do this. And let's start with like a real general equation. So we're going to start with that ax squared plus bx plus c equaling 0. And we know that a, b, and c, those have to be real numbers. So let's just go through that completing the square process. Typically I like for us to isolate the constant term, either separate it or isolate it to the other side. So let's just isolate it to the other side by subtracting c. Next step was let's factor any coefficient on the x squared term. So we have to pull out an a, and when you factor out a coefficient, really what you're doing is you're dividing. So we need to divide by a, and we end up with a bracket x squared plus b over ax. Now this is the point in completing the square where we would look at that linear term. So let me again off to the side just write down what the coefficient of the linear term is. It's b over a. And what we would do is we would take half of that. So if we want to half something, we can just divide it by 2 or increase the denominator by a factor of 2. And then we square that term. So squaring b over 2a would result in b squared over 4a squared. Basically just square each term separately, or each piece separately. What we then do with this amount is that is what we add in or subtract off. In this case we're going to add in b squared over 4a squared, and we're also going to subtract it off, so that we're basically adding a net 0. Next step was always to expand out the negative constant that we just added in. So that would be b squared over 4a squared. When we factor that out, we multiply a times that term, we're going to have negative b squared over 4a. Notice one of the a's reduces. That equals negative c. Let's group the b squared over 4a over to the other side by making it positive. So b squared over 4a minus c. Now let's do two things here. Let's actually complete the square. We have an a out front. When we complete the square with x squared plus b over ax plus b squared over 4a squared, typically we look at the half term, and that's really what we add to create this perfect square. So it's x plus b over 2a all squared. There's our perfect squared. Sorry, our perfect square. And on the right hand side, let us find common denominator here. So it would be 4a over 4a times c, so that we can end up with a common denominator of 4a. One more step here. Let's just divide. Let me write this out again first. b over 2a all squared. We find a common denominator, so we can actually put it together. 4ac over 4a. Dividing by a, now we're starting to isolate. Now we're starting to isolate for the x. Dividing by a, we're going to have it over 4a squared. Because it's a perfect square, we can take the square root of both sides, and remember that introduces a plus or minus situation. So plus or minus b squared minus 4ac over 4a squared. Notice that in the denominator we have two perfect squares. We have a perfect square of 4 and we have a perfect square of a. So let's subtract b over 2a to isolate for x. We're going to have plus or minus the square root of b squared minus 4ac. And what I can do with that denominator of 4a squared is take it out of the root by square rooting both pieces, and we're left with 2a, which is actually a little bit lucky because that's already a nice common denominator for us. So we have negative b plus or minus the square root of b squared minus 4ac, and that is dividing by 2a. A little bit of a complex formula, I admit, lots of pieces to it, kind of square root, that sort of thing. Notice because of the plus or minus that we do end up with two possible roots. So, given the quadratic equation ax squared plus bx plus c equaling 0, where a, b, and c are constants, and a does not equal 0, the solution for x is given by, well, what we just saw above. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's a really handy formula. You're going to have to remember that. And let's do a couple examples on how we apply that. So what I would identify right from the start here is what a, b, and c are. Here a is 2, b is negative 5. Any negative signs have to be grouped with that a, b, and c. We have x equals negative b. I'm going to make sure I use brackets here when I replace stuff. Plus or minus the square root of b squared minus 4 times a times c. And that's entirely over 2a, 2 times 2. So we can find a nice exact value for this. We have x equals basically positive 5 now, plus or minus the square root of negative 5 squared is 25. Minus 4 times 2 is 8 times 3 is 24. So that's 25 plus 24, all over 4. 5 plus or minus the square root of 49 over 4. And root 49, fortunately, works out to a nice perfect square of 7. So 5 plus or minus 7 over 4. And this is where we're going to maybe break it up into our two options. We have the option of x equals 5 minus 7 over 4, or 5 plus 7 over 4. And we end up with 5 minus 7 is negative 2 over 4, so that's negative a half as one solution. And we have 12 over 4, which is 3. So what you could do is you could take those answers, those roots, and plug them back into the equation, check to see if they're roots, and go from there. Here, the second example, you're probably going to want to get rid of the fractions. In this case, we have division by 3. It's always useful, I think, to multiply everything by the lowest common denominator to get rid of it. So let's just multiply everything by 3. Let's see what happens here. The 3 times a third is just an x, and x minus 3 equals 28. Expanding that, x squared minus 3x equals 28, and x squared minus 3x minus 28 equals 0. So we got it to the point where we have a equaling 1, b equaling negative 3, and c equaling negative 28. Why don't you go ahead and hit pause here and see if you can do that one on your own. So let's slot that into the equation, the quadratic formula. Negative b, so negative of negative 3, plus or minus the square root of negative 3 squared minus 4 times 1 times negative 28, all over 2 times 1. So that's positive 3 plus or minus the square root of 9 plus 4 times 28 is 112 over 2. And that's 9 plus 112 is root 121 over 2. So again, that works out to be a fairly nice perfect square. So we get x equals 3 minus, plus or minus root of 121 is 11 over 2. And our two solutions are 3 minus 11 over 2, or x equals 3 plus 11 over 2. 3 minus 11 is negative 8 over 2, and we get an x value of negative 4, or we get 14 over 2, which is an x value of 7. So there we go. The quadratic equation, very useful if if you're having problems factoring. You can always just run stuff through the quadratic equation to find the roots of a quadratic. This ends the notes for the quadratic formula and solving quadratic equations.